Hello student, let's try to understand the spherical mirror. What is spherical? The reflecting surface of a spherical mirror may be curved inward or outward. A spherical mirror whose reflecting surface is curved inward, that is the face towards the center of the sphere, is called the concave mirror. A spherical mirror whose reflecting surface is curved outward is called the convex mirror. The systematic representation of this mirror is shown in figure 10.1. This you can see, student. You may note that this diagram that the back of the mirror is shaded. You may now understand that the reflection surface of a spoon curve inward can be approximate to the concave mirror, and the surface of the spoon bulge outward can be approximately to the convex mirror. Okay, so this surface is what is there, student, concave, and this one is called convex. So both are there here, student. Now, before we move to further spherical mirror, we need to recognize and understand the meaning of the few terms. These terms commonly used in discussion about spherical mirror. The center of reflecting surface of a spherical mirror is point called pole. It lies on the surface of the mirror. The pole usually represented by letter P. The reflecting surface of a spherical mirror form a part of a sphere. This sphere has center. This point is called center of curvature of the spherical mirror. It is represented by letter capital C. Please note that the center of curvature is not part of the mirror. It lies outside its reflecting surface. The center of curvature of the concave mirror lies in front of it. However, it lies behind the mirror in case of convex mirror. You may note this in the figure 10.2 A and B. So we have to see 10.2. So this is center of curvature, student. This center of curvature in front and center of curvature back side. Okay. Now the radius of sphere of which the reflecting surface of a spherical mirror form part is called a radius of curvature of the mirror. It is represented by letter capital R. You may note that the distance PC is equal to radius of curvature. Image, Imagine a straight line passing through the pole and center of curvature of a spherical mirror. This line is called principal axis. Remember that the principal axis is normal to the mirror at its pole. Let us understand important term related to mirror through the image. The paper at the first beginning to burn, producing smoke. Eventually it may even catch fire. Why does it burn? The light from the sun is converged at a point as sharp, bright spot by mirror. In fact, this spot of light is image of the sun on the sheet of paper. This point is the focus of the concave mirror. The heat produced due to the concentration of sunlight ignite the paper. The distance of the image from the position of the image give the approximate value of focal length of the mirror. Let us try to understand this observation with the help of ray diagram. Observe 10.2 closely. A number of rays parallel to the principal axis are falling on concave mirror. Observe the reflected rays that are all meeting interacting at the point of the principal axis of the mirror. This point is called the principal focus of the concave mirror. Similarly, observe in the 10.2b how the rays are parallel to principal axis reflected by the concave mirror, convex mirror. The reflected rays appear to come from a point of the principal axis. The point is called the principal focus of convex mirror. The principal focus is represented by letter F. The distance between the pole and the principal focus of a spherical mirror is called focal length. It is represented by letter F. The reflecting surface of a spherical mirror is by and large spherical. The surface then has the circular outline. The diameter of reflecting surface of mirror is called aperture. Distance mn represent the aperture. So which one is a mn, student? So this is the m and this is an n, that is called, student, aperture. We shall consider in our discussion only such spherical mirror whose aperture is much smaller than the radius of curvature. In is there a relationship between the radius of curvature r and focal length f of the spherical mirror? In a spherical mirror of a small aperture, the radius of curvature is found to be equal to the twice of focal length. We put that r is equal to 2f. This implies that principal focus of a spherical mirror lies midway between the pole and center of curvature. Image formation by a spherical mirror. You have studied about the image formation by plane mirror. You also know the nature, position, relative size of the image formed by them. However, the image formed by spherical mirror, how can we locate the image formed by concave mirror for the different position of the object? Are the image real, virtual? Are they enlarged, diminished, or have same size? We shall explore this with an activity. You will see in the above activity that nature, position, and size of the image formed by concave mirror depend on the position of the object in relation to point PFC. The image is formed is real for the same position of the object. It is found to be virtual image for certain other position. The image is either magnified, reduced, has the size same size depending on the position of object. Summary of these observations are given as: object position, if it is infinity, so it is image is at focus, highly diminished point size, real and inverted. Beyond C, so between F and C, diminished, real, inverted. At C, same size, real, inverted. Between C and F, beyond C, enlarged, real, inverted. At F, at infinity, highly enlarged, real, inverted. Between P and F, behind the mirror, enlarged, virtual, erect. Representation of image formed by spherical mirror using the ray diagram. We can also study the formation of image by spherical mirror by drawing a ray diagram. Considered an external extended object of infinite size placed in front of the spherical mirror. Each small portion of extended object act like point source. An infinity number of rays originated from each of these points. To construct the ray diagram in order to locate the image of an object, an arbitrarily large number of rays eman- emanating from a point could be considered. However, it is more convenient to consider only two rays. For the sake of clarity of the ray diagram, these rays are chosen that it easy to know their direction and reflection from the mirror. The intersection of at least two reflected rays give the position of image of the point of object. Any two of the following rays can be considered for the locating the image. So parallel rays always after reflection passes through the focus. Parallel rays appear to be coming from the focus. A ray parallel to the principal axis after reflection will pass through the principal focus in case of concave mirror, or appear to diverge from the principal focus in case of convex mirror. This is illustrated in the diagram. Second, a ray passing through the principal focus concave mirror of ray which is directed towards the principal focus of concave mirror after reflection will emerge parallel to the principal axis. This is illustrated. So if it is going to the focus, it will become the parallel. It is the, if it is passing, so appear to be parallel. The third one, a ray of light, ray passing through the center of curvature concave mirror, directed in the direction of the center of curvature of concave mirror after reflection, reflected back along the same path. This is illustrated in the figure. The light ray come back along the same path, become the incident rays fall in the mirror along the normal to the reflecting surface. So if they are center of curvature, same path, student. This is the same path. The fifth one, a ray incident obliquely to principal axis towards the point P, pole of the mirror on the concave mirror or a convex mirror is reflected obliquely. The incident ray reflected ray follow the law of reflection of point incident, making the equal angle. So if it is falling on the pole, then it will be reflected back and angle will be same. Remember that in all the above cases, reflection are followed at the point of incident. The reflected rays in such a way that the angle of reflection equal to angle of incident. Image formation by concave mirror. Figure 10 point illustrate the ray diagram for the formation of image by concave mirror in for the various position. So here you see, student, these are, if it is infinity, the image is at focus. Beyond C, so image is between C and F. At the C, so image is C. Between C and F, image is beyond C. And now at the focus, then the, if the image is at infinity, between the CFN, the image is where, student, behind the mirror. Use of concave mirror. Concave mirror are commonly used in the torches, searchlight, and vehicle headlight to get the powerful parallel beam of light. They are often used as a saving mirror to see larger image of the face. The dentist use concave mirror to see the large image of the path particles. Large concave mirrors are used to concentrate sunlight to produce heat in the solar furnace. Image formation by convex mirror. We study the image formation by concave mirror. Now we shall study the formation of image by convex mirror. We consider two positions of the object. Studying the image formed by the convex mirror. First is when the object is at infinity, and the second position is when the object is at finite distance from the mirror. The ray diagram of the formation of image by convex mirror for these two positions of the object is shown in the figure. So if the infinity is there, student, so it will form the at focus, and beyond pole is there, student, it will be between the C and F, student, here. So at infinity of there, so at the focus behind the mirror, highly diminished point size, virtually erect. Between infinity and the pole, student, between P and F, behind the mirror, diminished virtual. You have so far studied the image formation by the plane mirror of the concave mirror and convex mirror. Which of these mirror will give the full image of the large object? Let us do the activity. You can see full length of the image of the tall building tree in a small convex mirror. One such mirror is fitted in the wall of the Agra fort facing Taj Mahal. If you visit Agra fort, try to observe the full image of the Taj Mahal to view correctly. You should stand suitably at the terrace adjoining the wall. Use of the convex mirror. Convex mirrors are commonly used as a rear view mirrors in the vehicle. These mirrors are fitted in the side of the vehicle, enabling the drivers to see the traffic behind him or her, facilitate the safe driving. Convex mirrors are preferred because they always give erect through the diminished image. Also, they have wider field view, they are curved outwards, thus the convex mirror enable the driver to view much larger area than would be possible with the plane mirror. Sign convention of the spherical mirror, student. Mirror formula and magnification. This is the mirror formula. Magnification, height of image by height of object, or the minus b by u. So thank you very much for watching.